Welcome to the deep dive. Today we're doing something a little different. We're taking just one single source, a product specification sheet, and we're going to see what it tells us about industrial complexity and risk.
It's a really interesting one.
It is. The target is the NTI E-PST1000IS, Intrinsically Safe Pressure Sensor Transmitter.
Which is quite a mouthful.
It really is. And the first thing that jumps out is the price. $2,600.
For a single sensor.
Exactly. So our mission today is to unpack that.
Mm.
Why does it cost so much? What makes it so special?
Well, the biggest clue is right there in the name, the safety rating.
You mean the intrinsically safe part?
That and also Class 1 Division 1. And these aren't just, marketing buzzwords. They're mandatory, hard-earned certifications.
Okay, so let's break that down. What does intrinsically safe actually mean here?
It means the device is engineered from the ground up to be incapable of causing an explosion.
How?
It runs on such an incredibly low amount of power that even if it completely malfunctions, if it shorts out, whatever, it just cannot generate a spark. Wow.
Or enough heat to ignite any of the explosive gases or dust that might be around it.
And the Class 1 Division 1 part tells you where it's being used.
Exactly. That tells us this sensor is going into a place where those explosive concentrations of gas are present all the time under normal conditions.
So you're paying for this guarantee, certified by bodies like ATEX, that this one component will not be the thing that triggers a disaster.
That's the core of it.
But I'm looking at the specs here, and what's interesting is that even with that design, you can't just plug it in. It says it requires an external barrier.
Yes, the EISCB intrinsically safe barrier.
Right. And that's another, what, $810? It feels a little redundant.
It seems like it, but that's actually the critical question. The barrier isn't there to protect just the sensor. It's there to protect the entire system. Think of it like an ultra-sensitive fuse that sits outside the hazardous area.
I see.
It limits the voltage and current before it ever gets down the line to the sensor.
Yeah.
So even if there's a massive power surge back in the control room, it can't reach the sensor and overload its safety features.
You got it. It's a firewall.
So you're not buying a single component. You're really buying into an interlocking safety chain.
A whole ecosystem. And that's why it also specifies that it has to be used with certain NTI power units.
Right, the E2D, 5D, or 16D units, but only with the ES420 MA24V interface.
Correct. You can't just mix and match parts. If you do, you void the compliance, and frankly, you're creating a massive risk. The complexity is the price of certainty.
And that precision carries over into the physical construction, too. I mean, the material science is so specific.
It has to be.
It says the process connection is 18-inch BNPT male 316 stainless steel. Why does that matter so much?
Well, the material first. 316 stainless steel is incredibly resistant to corrosion, which is a huge issue in these chemical-heavy Division 1 environments.
Okay, that makes sense.
And the BNPT fitting, that's a British national pipe taper. The key word is taper. It creates a much, much tighter mechanical seal than a standard straight thread.
To prevent leaks.
You absolutely cannot have leaks in a high-pressure explosive atmosphere. So that connection type is, non-negotiable.
And then there's the scale of it all. The maximum cable length it supports is 1,000 feet.
Yeah, that's 305 meters.
That just paints a picture. This isn't monitoring a small boiler in a closet.
Not at all. We're talking about monitoring pressure along a huge pipeline or across a sprawling refinery. The data has to be reliable over these massive distances.
So when you really add it all up, the $2,600 for the sensor, the $810 for the mandatory barrier, the specialized ecosystem,
You're at nearly $3,500 for a single measurement point.
and you realize you aren't paying for the hardware. You're paying for the documentation, the certification, the absolute guarantee that this single point of failure won't fail.
Exactly. It's the ultimate cost of risk mitigation. The sheer investment shows you the staggering level of liability and engineering that goes into keeping these volatile places safe.
So here's a final thought for you to take away. If a single industrial sensor requires this much specific, proprietary, and expensive engineering just to stop it from creating an accidental spark, what level of unseen, undocumented risk are we just accepting every day in the non-regulated consumer environments all around us?